Hello friends, welcome to EduSat program. Today I will start differential equations. Differential equations. Differential equations. You know it very well what is meant by equation. So, differential equation, in each equation derivative is present along with the dependent and independent variables is called differential equation. An equation in which derivative is present, along with dependent and independent variables is called differential equation. Equation we know it very well, differential equation in which equation dy by dx is present or derivative is present or differential coefficient is present along with dependent and independent variables is called differential equation. Shortly we are going to write differential equation. An equation in which derivative is present, with dependent and independent variables, is called differential equation. In which, especially in any equation dy by dx is present or ds by dt or dv by dt, any derivative is present with dependent and independent variables, that equation is called differential equation. For example, y plus x dy by dx is equal to 5. The second one, y into d squared y by dx squared plus dy by dx minus y is equal to 0. See, that is not necessary only first derivative is present. It may be second derivative, it may be third derivative, any derivative must be present in the equation. Such equation is called differential equation. Similarly, we can give number of examples. Let us see the next point, order of the differential equation. Order of the differential equation. In equation, the highest derivative is called order of the that differential equation. Take the first example. What is the order of the first example? Y plus x dy by dx. First derivative y plus x dy by dx is equal to 5. Order of differential equation is 1. Second example, y into d squared y by dx squared plus x into dy by dx whole squared plus 8 is equal to 0. For this equation, order is 2. So, like this, highest derivative, what is the highest derivative what is the highest derivative in the given differential equation, that is the order of the differential equation. Now we will see the degree of the differential equation. 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 The highest degree of the highest derivative, highest degree of the highest derivative is called degree of the differential equation. Degree of that differential equation. Highest degree of the highest derivative. So see the second example of the previous one. Actually degree of the dy by dx is 2, but this is not the degree. Whenever we are going to write degree of the differential equation, we have to see the highest derivative. This is the highest derivative in this equation. So degree of this is 1. Similarly, other examples, y plus x into dy by dx plus y plus 1 dy by dx is equal to 0. Order of the differential equation is, order if we take, order is 1. So what is the degree? Order of this equation is 1. Highest derivative is first derivative in this equation, so it is 1. So what is the degree of that highest derivative? Degree is 2. Similarly, you take the second example, d squared y by dx squared plus x into dy by dx minus xy is equal to 10. So what is the degree of this equation? Let us see first what is the order. Order of this equation is 2. See, but what is the degree of this? Whole to the power of 1. So this is degree is 1. Similarly, if we take the third example, 3 into d cube y by dx cube whole squared plus d squared y by dx squared whole cube plus x into dy by dx whole to the power of 4 minus 4 equal to 0. Minus 4 is equal to 0. See, first you find the order, then easily you will come to know that what is the order of that equation. So highest order is the third derivative. So order is 3. Order is 3. So degree of that highest derivative. Highest degree of the highest derivative is the degree of that differential equation. For highest degree is this. So the degree is highest derivative is this. Degree of that highest derivative is 2. Don't take this 3, 4 is there. That is not the degree. So we have to take the highest derivative. So degree of that highest derivative is 2. So like this we can determine the order and degree of the given differential equations. Now we will see how to form the differential equation. How to form the differential equation. Formation of differential equations. Formation of differential equation. The differential equations can be formed by eliminating certain arbitrary constant in the relation. So, we can form the differential equations by eliminating the certain arbitrary constants in the given relation. We know it very well, differential equation means derivative must be present. Therefore, any equation is there, we have to differentiate it. But there is a rule is there. So, according to that, any arbitrary constant is present in that equation, first we have to see that to eliminate that arbitrary constant by differentiation. The differential equation can be formed by eliminating certain arbitrary constants in the relation. So, that means by differentiation we are going to eliminate the arbitrary constant, differential equation. Therefore, in that equation dy by dx or derivative must be present. Derivative must be present means what? We have to differentiate. Why we are going to differentiate? To eliminate the certain arbitrary constant. So, while doing problems we will easily understand that how to eliminate the arbitrary constants. Problems. First problem, form the differential equation of x squared plus y squared is equal to a squared, where a is arbitrary constant. Solution: given x squared plus y squared is equal to a squared, where a is the arbitrary constant. Differentiate with respect to x. Derivative of x squared is 2x plus derivative of y squared is 2y into dy by dx. Derivative of constant is 0. That is, divide by 2 x plus y dy by dx is equal to 0. That is the required differential equation. So, most probably you have understood how to eliminate the arbitrary constant. Let us see the second problem. Form the differential equation of y is equal to mx, where m is the arbitrary constant. Solution: given y is equal to mx. Look here friends, previous problem is different from this. Differentiate with respect to x. Dy by dx is equal to m. So, we have got it that arbitrary constant is equal to dy by dx. dy by dx is equal to m, in the given equation y is equal to mx. That is, y is equal to, in the place of m, dy by dx into x, that is x into dy by dx minus y is equal to 0. This is the differential equation of the given y is equal to mx. Third one, form the differential equation, y is equal to a into e to the power of x plus b into e to the power of minus x, where a and b are arbitrary constants, where a and b are arbitrary constants. In this equation, we have to eliminate the two arbitrary constants a and b. Generally, if there is a one arbitrary constant is there, one time we are going to differentiate. If there two arbitrary constants are there, twice we are going to differentiate. That means second order derivative will be present in the given differential equation. Solution: y is equal to a into e to the power of x plus b into e to the power of minus 6. Differentiate with respect to x. That is dy by dx a into e to the power of x. A is coefficient, keep it as it is. Derivative of e to the power of x is e to the power of x. Minus b e to the power of minus x. Actually, we have to write here plus e to the power of minus x, derivative of that is this. So, directly we can write plus into minus, minus. So, this is equal to a into e to the power of x minus b into e to the power of minus x. Again, differentiate with respect to x. Again, differentiate with respect to x. That is d squared y by dx square is equal to a into e to the power of x plus b into e to the power of minus 6. Here already minus is there. If we differentiate this e to the power of minus 6, we are going to get minus e to the power of minus 6. So, minus into minus plus, that is equal to y, a e to the power of x plus b e to the power of minus 6, that is equal to y. So, in the place of this we can substitute y. So, we can't see that a and b. Like this we are eliminating arbitrary constants a and b. That is d squared y by dx squared minus y is equal to 0 is the required differential equation. There are two arbitrary constants, so twice we have differentiated. Just you look at here. What is the degree of the order of this? 2, but degree is 1. Like this, for every problem, just if you verify like this, you can easily remember order and the degree. Next one, form the differential equation. Of xy is equal to a into e to the power of x plus b into e to the power of minus x plus x square, where a and b are arbitrary constant. arbitrary constant. Same method, but here extra he has given xy is equal to a into e to the power of x plus b into e to the power of minus x plus x squared. Again there are two arbitrary constants are there. We have to differentiate twice. So we will see what we will get. Solution. Given xy is equal to a into e to the power of x plus b into e to the power of minus x plus x squared. Differentiate with respect to x. It is a product x into y, xy. It is a product. First one keep it as it is, derivative of the second one, plus second one keep it as it is, derivative of the first one. This is a product rule. It is well known for you. Derivative of a into e to the power of x, a e to the power of x, e to the power of x, minus b into e to the power of minus x. So minus we are going to get plus into minus minus, plus 2x. That is, differentiate with respect to x. Differentiate with respect to x. Better you write. Again, differentiate with respect to x. First one keep it as it is, d squared y by dx squared, plus second one keep it as it is, derivative of x is 1, plus derivative of y is dy by dx. So RHS a into e to the power of x minus into minus plus, we are going to get plus 2. See this. So this value is equal to xy minus x squared. From the given equation, from the given equation, a e to the power of x plus b e to the power of minus x is equal to xy minus x squared, xy minus x squared. That is, so in this equation, if we substitute that a e to the power of x plus b e to the power of minus x is equal to xy minus x squared, you will get the differential equation by eliminating the arbitrary constants a and b. That is, x into d squared y by dx squared plus 2 into dy by dx is equal to xy minus x squared plus 2. See that in this is equal to xy minus x squared is the required differential equation. So slightly you have to concentrate it properly. First time product, again it is a product. So while doing the product, should be careful. Product rule you should know that, then only you can do it properly. So this is the differential equation of the given function. Form the differential equation of y is equal to a sin mx plus b cos mx, where a and b are arbitrary constants, where a and b are arbitrary constants. Where a and b are arbitrary constants. Solution. Given y is equal to a into sin mx plus b into cos mx. Again two arbitrary constants are there, so we have to differentiate twice. Differentiate with respect to x. Differentiate with respect to x. dy by dx a m cos mx. For sin you will get cos, for mx you will get m, plus b coefficient, write as it is, cos mx for cos minus sin mx, for mx m we will get. This is equal to, m is common, I will take outside, a cos mx minus b sin mx. Again differentiate with respect to x. d squared y by dx squared, m constant, a into cos mx, a coefficient, you write it as it is, derivative of cos is minus sin mx into m, minus b, derivative of sin is cos, derivative of mx is m. So this is equal to minus m already is there, minus I have taken on side, another m is m a sin mx plus b cos mx. This is equal to minus m squared into 1. Look at the board. A sin mx plus b cos mx is equal to y. It is given. Therefore, d squared y by dx squared is equal to minus m squared y. That can be written as d squared y by dx squared plus m squared y is equal to 0. It is the required differential. It is the required differential equation. Form the differential equation of y is equal to ax plus bx squared, where a and b are arbitrary constants. Where a and b are arbitrary constants. Given y is equal to ax plus bx. I told you in the beginning itself, two arbitrary constants are there, so we have to differentiate twice. Differentiate with respect to x. Differentiate with respect to x. dy by dx, derivative of ax is a plus 2bx. That can be written again. Better you first you differentiate. Again differentiate with respect to x. d squared y by dx squared is equal to 2. Call this equation 1, call this equation 2, call this equation 3. From 3, b is equal to half of d squared y by dx squared. From 2, from equation 2, a is equal to dy by dx minus 2bx. Is it? A is equal to dy by dx minus 2bx. We know that b value is equal to, so this is equal to dy by dx minus 2 into half of d squared y by dx squared into x. This is equal to dy by dx minus x into d squared y by dx squared. So b is equal to this, a is equal to c, this. So see here, in this equation directly by differentiating we didn't get the differential equation. In this equation we have to substitute the arbitrary constants values in the original function. Substitute a and b in y is equal to ax plus bx squared, that is y is equal to a value is dy by dx minus x into d squared y by dx squared x plus x squared by 2 d squared y by dx squared is the required differential equation. But you have to observe that in which equation we are going to substitute in the original equation arbitrary constants value. So in some equations directly by differentiating itself we will get the answer. We have seen earlier. Let us take another problem. Y square, form the equation of differential equation of y squared is equal to 4ax, where a is the arbitrary constant, So these are all very simple problems. Given y squared is equal to 4ax, that is differentiate with respect to x 2y dy by dx, that is equal to 4a. Put 4a is equal to 2y into dy by dx in the given equation. Y squared is equal to 4ax, that is y squared. In the place of 4a you substitute 2y dy by dx into x. Both the side y is there, get cancelled, that is y is equal to 2x into dy by dx, that is 2x dy by dx minus y is equal to 0 is the required differential equation. So another one which is very simple. Form the differential equation of xy is equal to c square, where c is the arbitrary constant. Given xy is equal to c square, differentiate with respect to x. X into y, it is a product. Use the product rule. First one keep it as it is, derivative of the second one, plus second one keep it as it is, derivative of the first one. Constant, c is a constant, whatever it is, it may be arbitrary constant, absolute constant, it is a constant. Derivative of constant is 0, that is x into dy by dx plus y is equal to 0. This is the required differential equation. Next, form the differential equation of y is equal to ax plus a minus a square. Just you see the difference between these two. Directly by differentiation we got the required equation, but in this equation we have to substitute the value of arbitrary constant a in the original equation. Solution: given y is equal to ax plus a minus a square. Differentiate with respect to x. Differentiate with respect to x. dy by dx is equal to a, derivative of x is 1 plus 0 minus 0. That is, a is equal to dy by dx. A is equal to dy by dx. Simple. Put a is equal to dy by dx in the original equation. Y is equal to ax plus a minus a square. That is itself a differential equation. That is, y is equal to x into dy by dx plus dy by dx minus dy by dx whole square. So this is the differential equation of the equation y is equal to ax plus a minus a squared. Y is equal to k into sin inverse x, where k is arbitrary constant. Where k is arbitrary constant. Where arbitrary constant. Given y is equal to k into sin inverse of x. Differentiate with respect to x. Differentiate with respect to x. dy by dx dy by dx dy by dx is equal to k into 1 over root of 1 minus x square. That is, k is equal to root of 1 minus x squared dy by dx by cross multiplication. Put k is equal to root of 1 minus x squared dy by dx in y is equal to k into sin inverse of x. That is, y in the place of k root of 1 minus x squared into dy by dx into sin inverse x. Therefore, dy by dx is equal to y divided by root of 1 minus x squared into sin inverse of x. This is the required differential equations. I think so you understood what is meant by differential equations, what is meant by order and degree of the differential equations, how to form the differential equation when the ordinary equation is given. So by eliminating the arbitrary constants, by doing differentiation, we can easily remove the arbitrary constants from the equation. In some equations directly we will get the differential equations. In some problems we have to substitute the value of the arbitrary constants in the original equation. Now we will go to the next. How to solve the differential equations. How to solve the differential equations. We know it very well. Differential equations means in any equation dy by dx is present. That means derivative is present. Derivative is present. That is called the differential equation. When the differential equation is given, how to find the original function? That is the solution of the differential equation. That means we know it very well. When the function is given, how to find the differential equation? By differentiation. Along with that, by eliminating the arbitrary constants. So when the derivative is given, how to find the original function? We know it very well. By integration, we can easily find the original function. The same method here is also we are going to follow, but some certain conditions are there. Directly if we integrate it, we won't get it. So we have to write in the proper order, then only we can integrate, then we will get the solution of the differential equation. Solutions of the differential equation. The first method of solving the differential equation is variable separable. Variable we know it very well. Variable means in Kannada avyakta pada. Separable, we are going to separate it. So two variables are there, x and y. We are going to make it the terms which are connected with x one side, the terms which are connected with y another side. So that is the variable separable. Variable separable. We are going to separate the variables x with dx, y terms with dy. That is called the variable separable. So in the simple way, m dx plus n dy is equal to 0, where the terms which are present in m, all x terms, are functions of x. N, the terms which are connected with y are present in n factor. So n is the function of x, n is the function of y, where m and n are functions of x and y respectively. So once if we separate like this, the terms which are connected with x put with dx, the terms which are connected with y put along with dy. So once if we separate, make it a group like this, just by integrating we will get the solution of the given differential equation. Let us take the very simple example, simple problem. Solve x plus y dy by dx is equal to 0. Very simple example I have taken. X plus y dy by dx is equal to 0. Solution: one term given x plus y dy by dx equal to 0. One term, keep it RHS. You take the another term that side, that is RHS. LHS x, this is equal to minus y dy by dx. That is x into dx is equal to minus y into dy, just like a cross multiplication. See that m dx plus n dy is equal to 0. See, m dx, is equal to minus n dy. If you take this side, it is become plus, whether it is plus or minus, but we have make it a group, x along with dx, y with dy. That is x dx plus y dy is equal to 0. Integrate both the sides. Integrate both the sides. Integration of x dx plus integration of y dy, that is equal to, where k is integral constant. We know it very well. Whenever you integrate, so you will get the constant value. That constant is called the integrating constant. So this is, if you integrate x into dx, x squared by 2 plus y squared by 2 is equal to k. So you might have seen that third example, x squared plus y squared is equal to a squared, where a is the arbitrary constant. Form the differential equation. Say, take the LCM, you will get x squared plus y squared is equal to 2k. Okay, whatever it is, that is constant only. So you have got it, x squared plus y squared is equal to a squared, is it? So this is the solution of the differential equation, x plus y dy by dx is equal to 0. So you have to remember the first method, which is very important for the examination point, variable separable. ಅವ್ಯಕ್ತ ಪದಗಳನ್ನು ಸಪ್ರೇಟ್ ಮಾಡಿ ಒಂದೊಂದು ಗುಂಪಾಗಿ ಪರಿವರ್ತಿಸ್ತೀವಿ ಅಷ್ಟೇ. ಅಲ್ಲಿ ಏನು ನೀವು ಮಾಡ್ತಾ ಇಲ್ಲ ಕಷ್ಟಪಡುವಂಥದ್ದು. ಯು ಆರ್ ನಾಟ್ ಗಿವಿಂಗ್ ಎನಿ ವರ್ಕ್ ಟು ಯುವರ್ ಮೈಂಡ್, ಜಸ್ಟ್ ಯು ಆರ್ separating the variables. All x terms are with dx, all y terms are with dy. How to separate it? If you have two terms, you make one term that side, one term this side. LHS is equal to RHS. Just you do the cross multiplication, you will get all x terms with dx, all y terms with dy. The second problem, solve the second one, solve x squared into dx plus y squared into dy is equal to 0. Just to observe that y terms are connected with dy and x terms are connected with dx. Here it is not necessary to do the variable separable. The given problem is itself a separating the variables. Just to integrate that, you will get the answer. What you have to observe, x squared, whether x squared with dx or not, y squared with dy or not. But in this case, just you see that x plus y dy by dx is equal to 0. So y is with dy by dx, x is free. So first you take this side to this side and just cross multiplication, then you will get the x along with dx and y with dy. You integrate the, you will get the differential equation. In the similarly, once if you come to know that x terms are with dx and y terms are with dy, directly you integrate that. Given x squared dx plus y squared dy equal to 0. Integrate both the sides. Integrate both the sides. Integrate both the sides. X squared dx plus y squared dy, this is equal to k, where k is integral constant. That is x cubed by 3 plus y cubed by 3 is equal to k. This is the solution of the given differential equation. You observe the third one, solve x into dy plus y into dx is equal to 0. The same problem we can easily write it the same way. X into dy plus y into dx. So x terms are with dy, y terms y is with dx. So we have to change it, x with dx, y with dy. Solution: given x into dy plus y into dx is equal to 0. That is one term in LHS. Take the another term RHS. That is, see y, it comes in the numerator of this, dy by y is equal to minus dx by x. I don't think so it is very difficult for you. Easily you can do the variable separable by cross multiplication. Integrate both the sides. Integrate both the sides. Integrate both the sides. Integration of dy by y is equal to minus integration of dx by x plus log k. I will explain afterwards why I have taken in the place of constant log k. First term, integration of dy by dx, that is log of y is equal to minus log of x plus log of k. Whenever you will get all the terms after integrating log, then you take the constant is also log of k. Then you can easily simplify that. Even if you take k, there is no mistake, you will get full marks, you need not worry about that. But you can do the further simplification. That is log of y plus log of x is equal to log of k. You know that log m plus log n, you have studied in your previous sum. Log m plus log n is equal to log m into n, that is log m into n. In the bracket, log m plus log n is equal to log of m into n. So both the side log is there, xy is equal to k. Or you remember, I did the problem, xy is equal to c squared. Form the differential equation. Form the differential equation, xy is equal to c squared, where c is arbitrary constant, k is equal to c squared. The same problem, we have got it back. Is it? Next. Solve square root of 1 plus 6 dy plus root of 1 plus y dx is equal to 0, or dy by dx is equal to root of 1 plus y divided by 1 plus 6. Both are one and the same. If they give like this, you take one term in LHS, the another term is RHS. This is directly you can do the cross multiplication when it is given like in this form. Let us take the first one. Given root of 1 plus 6 dy plus root of 1 plus y dx. That is, one term is in LHS, another term minus of 1 plus y dx. That is, by cross multiplication, see, even here also cross multiplication, dx will go here, 1 root of 1 plus y come here. Directly you can do the cross multiplication, but in this you have to take the one term that side, afterwards you have to do the cross multiplication. Now if you integrate, you will get the solution of the differential equation. Integrate both the sides, integrate both the sides, integration of dy by 1 plus y is equal to minus integration of dx by root of 1 minus x plus k. K is the integral constant. This is equal to that is 1 over root x. Integration of 1 over root x is 2 root x. 2 root x. 2 root of 1 plus y is equal to minus 2 root of 1 plus x plus k. That is 2 root of 1 plus y plus 2 root of 1 plus x is equal to k. This is the solution of the given differential equation. Here you have to observe, so one problem is there, but in the two ways we can give. So here itself we can see the another problem. Suppose if we remove the square root, if there is no square root, what we are going to write? Square root is there here, square root is not there. Just imagine like that, there is no square root. So what we are going to get? Integration of dy by 1 plus y is equal to minus integration of dx divided by 1 minus, this is 1 plus. Okay, there is no much difference taking minus and plus sign, but of course coefficient of x is minus 1. So suppose if there is no square root here, then we are going to get log of 1 plus x. This is log of 1 plus x is equal to minus log of 1 plus x. Then we have to take in the place of k log of k, previous problem. Then we are going to get log of 1 plus x plus log of 1 plus y is equal to log of k. Then log of 1 plus x into 1 plus y is equal to log k. K get cancelled. We will get 1 plus y into 1 plus x is equal to k. That is the answer if there is no square root. Okay friends, I will continue in the next class.